For 4 years, Russia has committed armored columns, infantry waves, artillery barrages, and the full weight of its ground force doctrine to the Eastern Front in Ukraine. For 4 years, the territorial map has shifted by margins that bear no relationship to the human cost of producing them. When the ground campaign fails to break Ukraine's defensive lines at acceptable cost, and when the industrial machine that feeds the war begins grinding against the limits imposed by Western sanctions, the strategic calculation changes. Pressure shifts from the horizontal plane, tanks and soldiers moving across ground, to the vertical plane, waves of Shahed attack drones, Lancet loitering munitions, and cruise missiles arriving over Ukrainian cities every night. Cheap, mass-produced, sent in mixed packages, designed not necessarily to hit specific targets, but to exhaust Ukrainian interceptors, reveal defensive positions, and open gaps for more lethal follow-on strikes. Unable to break Ukraine's army on the front, Russia is trying to break Ukraine's cities from above. In the middle of that air campaign, a weapon that most people had quietly stopped thinking about has returned to relevance. Ukrainian crews have given it a nickname, the murder pencil. It does not hunt heat signatures. It cannot be tricked by flares. It cannot be confused by electronic warfare of any kind. Its official designation is Starstreak. And 4 years into the war that it entered at the beginning, Russia has still not found a reliable answer to it. Understanding why Starstreak matters requires understanding what makes it different from every other very short-range air defense system in use, because the distinction is not simply speed or range or warhead yield. It is the guidance method, and that difference is fundamental. Most shoulder-fired air defense missiles are infrared seekers. The operator acquires a target. The seeker head on the missile detects the heat signature of the target's engine or exhaust, and when the audio tone confirms the lock, the operator fires and is free to move immediately. Fire and forget. The missile chases the heat on its own. The operator does not need to stay exposed after launch. This approach has significant operational advantages. It is mechanically straightforward to execute under pressure. It keeps operators alive by allowing them to relocate immediately after firing. It places no sustained demand on the operator's attention after the shot is taken. It has one substantial vulnerability. Heat-seeking missiles can be given something hotter to chase. Modern aircraft carry flare dispensers as standard equipment. Infrared countermeasure systems generate competing heat signatures. A disciplined evasive turn combined with a well-timed flare deployment can convert a high-probability kill into a coin flip. Against a well-equipped opponent with functioning countermeasures, the infrared seeker's certainty of kill degrades significantly. Starstreak was designed to eliminate that vulnerability entirely. The system uses laser beam riding guidance. After the operator fires, an aiming unit projects a coded laser beam onto the target. The missile does not chase heat. It follows the laser beam, riding a path defined entirely by where the operator is pointing. As the target moves, the operator tracks it through the sight, and the beam moves with the sight. The missile follows the beam. The target can dispense every flare in its inventory. It can activate every infrared countermeasure system it carries. It can maneuver aggressively. None of that changes anything about where the laser is pointing. The missile follows the beam regardless of what the target does to the electromagnetic and thermal environment around it. Thales, the manufacturer, describes the guidance as immune to all known infrared and radio frequency countermeasures. That claim sits at the center of why this system remains relevant in a war that has changed almost everything else about how air defense is conducted. The firing sequence itself is worth understanding because the engineering decisions reveal the design philosophy. When the operator pulls the trigger, a first-stage motor ignites inside the launch tube. It burns out deliberately before the deployment module has fully cleared the tube, a safety feature that protects the operator from backblast. Once the module is at a safe distance, the second stage ignites and accelerates the missile to over Mach 3, by some accounts approaching Mach 4, in a fraction of a second. Then the second stage burns out and releases the payload. This is where the nickname becomes accurate. Starstreak does not release a single warhead. It releases 3 smaller submunitions simultaneously, laser-guided tungsten darts, each approximately 390 millimeters long, housed in a missile body roughly 1.5 meters in length. Each dart carries explosive material in its rear section and is fitted with a delayed action impact fuse. The delay is the critical design element. The dart does not detonate on contact with the outer surface of a target. It punches through the armor or airframe first, then detonates inside, past the reinforced structure, inside the operational components. 3 darts arriving simultaneously, each guided independently, each detonating inside the target, rather than against its exterior. Against a helicopter's rotor assembly or fuel system, 3 laser-guided tungsten darts moving at over Mach 3 and detonating internally represent a level of kinetic and explosive damage that is extremely difficult to survive. Against aircraft in general, the combination of simultaneous multiple impact probability and internal detonation makes the system exceptionally lethal. The first documented kill attributed to Starstreak in this war came in early April 2022, days after the system entered Ukrainian service. Footage showed a Russian Mi-28 attack helicopter losing its tail boom over the Luhansk region as it flew at low altitude. UK Ministry of Defense sources identified the strike signature as consistent with Starstreak. The attribution was not officially confirmed by Russia, but the visible characteristics of the strike matched nothing else in the Ukrainian inventory at that time. A weapon that most people outside NATO had never heard of suddenly attracted considerable attention. Subscribe now if this level of detailed technical and strategic analysis on the weapons shaping this war is what you want from this channel. Starstreak comes in multiple configurations, and the platform determines the tactical application significantly. The shoulder-launched version is the most flexible. A trained operator can assemble it and be ready to fire in seconds, engage from virtually any covered position, and relocate immediately after firing. The limitation is coverage. One operator with one launcher can only address a narrow slice of the attack vectors a modern aerial threat can exploit. The lightweight multiple launcher holds 3 missiles in a ready-to-fire configuration. An operator can engage 3 sequential targets without reloading, and the launcher can be mounted on a light vehicle with a modest retrofit, adding mobility without sacrificing the essential man-portable flexibility. The version doing the most operationally significant work in Ukraine in 2026 is the Stormer HVM. The Stormer is a British tracked armored vehicle adapted specifically for very short-range air defense. Its roof-mounted launcher carries 8 Starstreak missiles in ready-to-fire configuration with 12 additional rounds stowed inside the hull. A 3-person crew operates the system. The launcher is integrated with what the manufacturer calls an air defense alerting device, an infrared scanner and processing system that automatically detects incoming air threats, prioritizes them by threat category, and slews the weapon sight onto the selected target before the crew would otherwise have become aware of the threat. That last capability matters more than it might initially appear. The hardest problem in very short-range air defense is frequently not the interception itself. It is the detection. Small drones operating at low altitude can be quiet, slow on radar return, and masked by terrain or urban clutter. A crew that discovers a threat when it is already overhead has lost the engagement before it began. The alerting device provides the critical few seconds that convert a missed engagement into a successful one. The Stormer also provides armor protection for the crew, strategic mobility between positions, and the ability to displace after firing. What artillery doctrine calls shoot and scoot. A man standing in a field with a shoulder launcher becomes a target the moment he fires. A Stormer crew fires, displaces under armor, and sets up again from a new position. The operational environment these systems are now working in bears almost no resemblance to the one they were designed for. When Starstreak first arrived in Ukraine in early 2022, the primary threat was conventional low-flying Russian aircraft and attack helicopters, the exact threat profile the system was built to defeat. By 2026, the aerial threat package over Ukrainian cities and frontline areas includes Shahed one-way attack drones, Lancet loitering munitions, Orlan 10 reconnaissance drones, Zala strike drones, decoy platforms designed to look like more capable threats, and cruise missiles, all arriving in mixed packages at varying altitudes, on varying approach routes, and in varying quantities. The operational logic of this mix is deliberate. A single threat category allows a defender to optimize against it. Mixed packages force the defender to address multiple threat types simultaneously, create ambiguity about which contacts represent the highest priority, force expensive interceptors to be spent on cheap targets when cheaper interceptors are not available, and reveal defensive positions when they fire. The 1129th Bielotserkva Anti-Aircraft Missile Regiment is one of the Ukrainian units that has adapted Starstreak and the Stormer to this environment. Ukrainian reporting has credited individual Stormer vehicles in this regiment with dozens of confirmed kills. More recently, crews have integrated the Stormer with a new generation of purpose-built interceptor drones, cheap quadcopters and fixed-wing chasers like the Ukrainian Sting, designed specifically to run down Shahed drones at lower cost than a missile. A Stormer commander has stated publicly that the system has been used against Shahed attack drones, against Orlan reconnaissance drones, against Lancet strike drones, and against at least one cruise missile. A weapon conceived in the era of the attack helicopter has become a frontline component of the answer to a drone war that did not exist when it was developed. Starstreak operates alongside a companion system that is worth understanding separately because the two cover each other's weaknesses in a way that makes the pair more effective than either alone. The Martlet is a lightweight multi-role missile used alongside Starstreak in British service and supplied to Ukraine. It weighs approximately 13 kilograms, has a range exceeding 6 kilometers, reaches over Mach 1.5, and uses the same laser beam riding guidance family as Starstreak, immune to the same countermeasures. The critical difference is the warhead, where Starstreak uses 3 dense tungsten darts designed to penetrate before detonating. Martlet carries a triple-effect warhead, a shaped charge combined with a blast fragmentation sleeve, triggered by a laser proximity fuse. That proximity fuse changes the engagement geometry against small targets. A dart traveling at Mach 3 requires a direct hit on the target to transfer its energy. Against a helicopter or fixed-wing aircraft, direct hits are achievable because the target is large. Against a small drone with a minimal physical profile, the probability of a dart scoring a direct hit decreases with the size of the target. A warhead that detonates near the target and disperses fragmentation in a sphere around the detonation point is far more forgiving against small maneuvering drones. The Martlet does not require a direct hit to destroy a small drone. It requires proximity. In practice, Starstreak against larger targets where direct hit probability is high and penetration before detonation is the desired effect. Martlet against smaller, more elusive targets where proximity detonation is more reliable. The pair creates a coverage spectrum that neither system provides alone. In September 2024, the UK confirmed a replenishment order worth approximately $216 million for the Martlet, with hundreds of missiles heading to Ukraine in the initial delivery. The scale of that order indicates how heavily the system had been used and how seriously Britain assessed its continued operational importance. An honest analysis requires stating clearly what Starstreak cannot do, because its limitations are real and operationally relevant in the 2026 threat environment. The guidance method that makes Starstreak immune to countermeasures is also its primary operational constraint. The operator must maintain continuous optical track on the target from the moment of firing until impact. The missile follows a beam the operator is holding on the target. If the operator loses the target in the sight picture, through smoke, dust, terrain masking, or visual distraction, the guidance degrades. In a sky filled with small, fast, low-signature drones approaching on unpredictable flight paths, maintaining continuous optical track under pressure is genuinely demanding. Adverse weather reduces visibility. Smoke and dust can distort the laser beams the missile follows. A target that makes an unexpected course change at the wrong moment can break the operator's track. This is not a trivial limitation. Against the saturated mixed package attacks Russia now sends, an operator may be attempting to track one target while simultaneously processing information about 3 others. That cognitive load, under time pressure, in conditions that may include smoke and debris from previous strikes, creates engagements where the system's theoretical capability does not always translate directly into kills. There is also the cost equation. Starstreak costs between $100,000 and $130,000 per round depending on configuration. Russia's Shahed drones cost in the range of $10,000 to $50,000. Against the lower end of that spectrum, the cost-exchange ratio runs at roughly 10-to-1 in Russia's favor when a Starstreak is used against a Shahed. That arithmetic does not make Starstreak the wrong choice when it is the available option, but it makes the case for pairing it with cheaper interceptors, the purpose-built drone chasers, when the threat does not require the full capability of the more expensive system. There is also a data gap. Comprehensive, independently verified kill rate data for Starstreak against specific drone target categories is not publicly available. Ukrainian crews are clearly using the system at significant volume, and early reporting has been encouraging. Intelligence assessments from April 2022 credited at least 7 Orlan-10 reconnaissance drones to Starstreak in the Kharkiv area. But whether those early performance indicators hold across the full range of 2026 threat packages has not been confirmed by verifiable independent data. None of this changes the fundamental assessment. In a layered defense, no single system is expected to solve every problem. Starstreak solves a specific problem: laser guidance immune to countermeasures, lethal against the larger and faster threats in Russia's mixed packages, that no other available system in Ukraine's inventory addresses in the same way. The reason Starstreak is back in the headlines 4 years after its introduction is almost entirely about what has changed in the war around it, rather than what has changed in the weapon itself. On the ground, Russia's spring 2026 offensive has produced results that do not justify the cost. In May 2026, Russian forces captured approximately 14 square kilometers of territory, the smallest monthly gain since October 2023, despite launching over 35% more assault attempts than the month before. More attacks producing less ground. The Institute for the Study of War assessed that Ukrainian forces have largely halted Russia's spring-summer 2026 offensive, with Russia establishing a presence in only a fraction of the territory it took in the same period in 2025. Ukraine has reclaimed ground in several sectors, producing net territorial gains for Ukraine over the past several months. Behind the front, the industrial machine is under sustained pressure. Western sanctions have progressively degraded Russia's access to components required for advanced weapons production. Ukrainian long-range drone strikes against oil refineries and processing infrastructure are hitting the revenue base that funds the war. Putin is simultaneously losing money, consuming men at unsustainable rates, and failing to convert that consumption into the territorial gains that would justify the cost domestically. When the army cannot advance, when the factories cannot keep pace with attrition, and when the oil revenue is burning in drone-struck refineries, what remains? Pressure from the air. The Institute for the Study of War has directly linked Russia's escalating urban air campaign to its failures on the battlefield, framing the drone and missile strikes against Ukrainian cities as both a substitute for ground progress and a distraction from Ukraine's successful deep strikes into Russian territory. The aerial campaign rests on a theory that enough cheap drones in enough mixed packages at enough volume will eventually overwhelm any defense. Quantity as a form of quality. But that theory runs into trouble when the defender has a guidance system that does not respond to countermeasures, a detection system that addresses the warning time problem before the operator would otherwise be aware of the threat, and 4 years of operational experience running the specific engagement type Russia is generating. Russia designed its aerial campaign to exploit the weaknesses of conventional air defense. Starstreak was designed against a different threat, but happens to address the specific weaknesses Russia has tried to exploit: countermeasure immunity, precise guided intercept against maneuvering targets, lethal engagement at the altitudes where low-flying threats operate. A weapon built for the helicopter threat of the Cold War has found operational relevance against the drone threat of 2026. Not because it was designed for this application, but because the guidance principle it is built around is precisely what the current threat environment demands. The darts are still tungsten. The laser still does not care about flares. The crews have 4 years of operational experience that no manual contains. And Russia, after 4 years of trying, still has not produced a reliable answer to a British missile that most people had stopped thinking about. Stay with this channel. The air defense dimension of this war is evolving faster than most reporting captures. And what comes next in the exchange between Russia's aerial campaign and Ukraine's layered response is a story worth following closely.